Okay, hi, I'm Milinder, and we're here to talk about our network's case study regarding a departmental store, which is called PIXTREME. And my group members are Pravinan, Ronald, and Roland. Okay, so introducing to this network, we are required to design a network for a departmental store, which is a four-floor building, which has one router, and each floor will be having one switch. So there will be a total of 5 switches. There are 5 departments in our store network: the sales department, the finance department, the inventory and delivery department, as well as the IT and admin department. So we have to assign each of the departments to a VLAN. So as you can see, this is our topology and design. This actually, we have shown this in the using the hierarchical model logical layout. So we have the router as our core layer, we have a distribution switch in the distribution layer, and we have four other access switches to which each VLAN is connected to. And then this is the physical layout according to the building. So the third floor would be having the router, the distribution switch, and the third floor access switch with the terminals. The second floor will be having its own access switch with the terminals. The first floor will be having its own access switch as well as its terminals. And the ground floor is where our server is located, as you can see over here, with the ground floor access switch. A receive machine is connected to each floor. So from the ground to the third floor. And also the sales and the IT VLANs will be located on the ground floor, the inventory on the first floor, finance on the second, and admin on the third. So in our logical layout, we have split it in terms of VLANs. So basically, there are 6 VLANs in our network, one for each department, 10 for sales, 24 delivering inventory, 30 for finance, 40 for admin, 50 for IT, and 100 for management. So then the below diagram will show the router connected in terms of VLANs, where each VLAN is connected to a physical subinterface for each router.
Okay, so I'm Roland here, going to talk about the OSI model and the VLANs and its implementations. So basically in the OSI model, a control is passed from one layer to the next, starting from the application layer, which is layer 7, in one station and proceeding to the bottom layer over the channel to the next station and back up the hierarchy. So in the application layer supports application and the end user processes. Layer 6, which is the presentation layer, this layer provides independence from difference in data representations, for example, encryption by translating from application to network format and vice versa. Next, we have the session layer, which is layer 5. This layer establishes, manages, and terminates connection between applications. Transport layer provides transparent transfer of data between end system or host and is responsible for end-to-end error recovery and flow control. It ensures complete data transfer. Next, we will have the network layer, which is layer 3. It provides switching and routing technologies, creating logical paths known as virtual circuits for transmitting data from node to node. The data link layer furnishes transmission, protocol knowledge and management, and handles errors in the physical layer, flow control, and frame synchronization. Last, we have the physical layer. The physical layer conveys the bit stream, electrical impulse, light or radio signal through the network at the electrical and mechanical level. It provides the hardware means of sending and receiving data on a carrier, including defining cables, cards, and physical aspects. I'm now going to talk about the VLAN implementations. What are the VLANs? It is an abstract of LAN through a subnet connectivity. A VLAN is associated with a broadcast domain and it is composed with one or more internet switches. So why do we use VLANs over IP subnets? Because it allows the physical device to create multiple switches within the switch, and it's more secure than IP subnets where data can be captured easily. What are the benefits of VLAN? So there are basically 3 points, which is security. It provides stacking frames with 8 O2.1q encapsulation protocol. The next is cost reduction. The number of hubs can be reduced and domains can be bundled into a loop. And it has a better performance, which is boosted by reducing the unnecessary network traffic.
Okay, I'm Pranath. I'm going to talk about layer 2 switching operations in a LAN. So in a remote connection, the host reaches a virtual interface known as intra VLAN. The switch acts as a router as it forwards the traffic directly to another network. So next is inter VLAN switching, which is basically routing of network traffic between network devices and end devices with the assistance of a router. So the routers are configured to forward the traffic between VLANs pre-configured on a switch. So as you can see on the diagram, the packets that have been destined to PCB leaves the PCA with the tag of VLAN 20, and it reaches the router and changes its tag to VLAN 30, and then it is forward to the switch, and the switch it is finally delivers to PCB. So that's it.
Okay, hi, I'm Ronald, and today I'll be introducing to you the STP processes and how STP was established within the PIXTREME departmental store. So what is STP? Well, STP was invented for a specific purpose, and in our store, the PIXTREME departmental store, we have implemented STP so that packets will not be forwarded again and again and again, creating several loops or broadcast storms which may affect the performance of the switches. So this is basically the definition of STP and why STP was involved in our project. In these days, modern switches, they normally come with pre-configured STP configurations. So it was not that difficult to implement STP in our project. Looking forward, what is STP and how STP actually affects the network? STP ensures that there is only one logical path between all destinations on the network by blocking redundant paths. STP also uses an algorithm called the STA, Standard Terminal Algorithm, or also called as Spanning Tree Algorithm. How does this algorithm work? It chooses one switch known as the base switch or the root bridge. This root bridge forwards packets all over the network and makes sure that there is only one logical path in which all the switches can reach each other end devices. So before moving further, let me move on to the next slide. So STP implementation in PIXTREME. As I said earlier, it was not that difficult to implement STP because all the switches these days are pre-configured with all these facilities to help in STP implementation. Well, in our departmental store, we needed only 5 VLANs together with a management VLAN called VLAN 100. So the 5 VLANs that we used, as spoken earlier by my colleagues, were VLAN 10, VLAN 20, 30, 40, 50, and finally 100. Here we use the distribution switch as our main root bridge. So this root bridge will forward packets between all the switches and make sure that there is no redundant paths or any loops caused within the network. So let's move on further without any delay. VLSM. So as I conclude STP, we come to a more important part called VLSM. VLSM actually is implemented in the initial stage of our network system. So what does VLSM do? VLSM actually identifies the various addresses that can be derived from a major IP network, which is basically derived from its name itself, variable length subnet mask. VLM is also used to break down the allocated network address into the 5 department subnets as well as an additional subnet for the management VLAN. So if you actually are interested in seeing how we have implemented VLSM in our network, let's move on to the next slide. Here we go. So as you can see here, the sales, finance, inventory, IT, admin, management, as well as the unused VLANs are being showcased in this table here. So for easy understanding, the network IP, subnet mask, broadcast, and the host IP range have been implemented in the table in a way that anyone can understand. So by means of this table, it is clear to see that from one major network IP, we have easily derived several major network IP as well as subnets to make sure that there's consistency maintained within the network. So let's move on to the next slide. Network configuration. Well, speaking about network configuration, this is a vast field. It denunciates any sorts of errors that is called upon in a network. Well, network configuration also was not that an obstacle. With a bit of determination and dedication from our team, we were able to bring it together a firepower, a firehouse within ourselves, in which we each other configured and helped and came into a solution where we configured each switch with all our own ideas, such as giving a VLAN for each switch with like deriving the numbers for the VLANs, or say deriving the VLSM parts, or all sorts of things. So in here, network configuration includes several steps, such as enabling the host name, configuring console login, configuring remote access, and so on. So all these tasks were divided into separate ways in our team, and each one took upon each task and contributed to the team in a very respectful manner, which I would say. Moving on further, the conclusion. So ultimately, what can we see from this project? We as a team have gained an enormous experience reading through this case study and going through all these activities, having sleepless nights, and I hope that we paid the cut that we were promised, and so on. Let me summarize by saying that PIXTREME departmental store will have no sort of obstacles or no sort of barriers coming further in its network implementation in its store or building, because we have designed a network in which 32,766 hosts can be a given space within a major network IP of 192.168.0 with a subnet IP of 17. So finally, thank you very much, and see you.